Hello folks, well, I'm at Mr. Chippy's bench, and today we've got a transistor radio which looks more complex than any of the others, probably because it's an old-fashioned design. And I bought this one. It's a pink one, so those of you who watch Big Clive, it would go with his pink calculator. I've not looked at this, it's not a sealed bag for some reason, but there you are. So what have we got? Well, this time we've got a fibreglass printed circuit board, and this radio is the WW818. I think it should be medium wave only. America don't call it medium wave, do they? They call it broadcast band, or AM. But AM can mean such a lot. So we'll look at this circuit diagram. It's got an input and output transformer, so that's kind of what you would expect for a 1960s type of transistor radio. So we've got the output transistors there in a push-pull configuration, driver transistor there. So that's our audio section, and then we've got 1, 2, 3, 4 transistors. So it's a 7 transistor radio. Good, one of those transistors will be being used as a detector. And as usual, we've got all the instructions here in Chinese, and it's all very detailed in Chinese. So we're trying to do different ones of these. I want to do about 10 of them. And we'll sit at a table outside with my posh HMV transistor radio made by Balfour for them in the 1970s, and then we can compare. We'll probably compare at any time. Ugh. To be honest, that's the most decent speaker we've ever had with these type of things, and it's 8 ohms, half a watt. I expect the transistor radio is probably 150 milliwatts if we're lucky, and this bag of parts is indeed sealed, unlike the bag the radio came in. I think it was customs inspected. There was a snag at the airport on the tracking at their end. I think it was searched. Ferrite rod. Let's hope we don't have a broken wire like we did on that one with shortwave. Is that Litz wire? Not quite sure. Tuning capacity, ferrite rod. That's going to be the output coil. That's going to be the input coil. We'll soon check anyway. What am I saying? Transformer. There's no digital meters on here. Mr. Chippy likes to use an analog meter. And that analog meter you see him with was about £150. It wasn't some cheap thing. What's it say? Yeah, you see, it's going to say that, isn't it? And this is where we want something less sophisticated. You can make this only read something in particular, but I wouldn't know what buttons to press to make it do that. So I'll have a quick look round. There may be something else. Anyway, we don't need to check those now. Have these got any labelling, or are they colour coded? We've got a red one, we've got a black one, we've got a yellow one, and we've got a white one. So they are colour coded, which we'll say in the instructions what colour is which in Chinese. the sensible thing to do is to fit the resistors first, and then we'll put the capacitors in, and so on. I'm going to be checking all capacitors for dodgy ones, and transistors will grade for the right kind of gain. We've got what have we got? 9018, 9018, 9018, 9018, then 9014, 9013, 9013. So we have 3 types of transistor, but I'll just stick them all in a pile and then we'll get the meter on them later. Now there is a diode. Where's that then? It's just to bring down the voltage. Yeah, they're using a transistor as a detector. I thought this was going to be one of these with less transistors in. I thought it was going to be one of the inferior performing ones, but that's not the case. So I think we've separated the nuts from the bolts. Let's get those electrolytics. Some of those look half decent, some of them don't. Let's get these capacitors. They're the diodes. They're not critical, a lot of these values, but we will check them to be somewhere where we'd expect. I didn't see 3 diodes in the circuit, but we've got 3. There we go. Right, so instead of Mr. Chippy putting this together, I'm going to put this together. See you in a bit. Okay, so I've put the resistors in and nearly all the small value capacitors. I've tested every component. Some of the capacitors are supposed to be 22 peak, no 2.2. I'll get it right. 22 nanofarads, aren't they? There's about 17, but it's not critical. So we need to sort these transistors. I put the diodes in, they're all the same type, 1N4148. Put all the resistors in, they were all pretty spot on. So here we go, we've got 3 different types. So we're supposed to have 9014. Did I show you I've got this? I did some translation with Google. Nine 14 9013 9018 9018 9018 9018 9018 9013. So they were our output transistors. Yeah, there and there. It'll go in between the driver and the output transformer. We'll just get our component tester. There's nothing worse than fitting duff components. So what we got? Base in the middle, green is emitter, blue is collector. So emitter, base, collector. emitter base collector. Is that what it says on the board? It is. So we'll get the other one of those and test it. Oh, something like 241 again. Yeah, 241. Hope this is somewhere close. .327, nothing like close. That's because that's the 2014. Lucky I checked these things. 9014. What am I talking about? Let's put that one in. So the other one is the other 9013. So just triple check, yeah. So what, we're 241 or something on the output. Try not to get the leads to touch. .241, it's precisely the same. There we go. Right, so there is 9 in. 9 leads. Took so long to do the translation for somebody like me who's not that good with computers that, well, I'm probably better with ones from the 80s. I was thought, oh, get this done in one evening, but no, I spent about an hour and a half doing the translation. Right, let's get these in some kind of order. So 1, 2, 3, 4, 5. Should have 4 left. We've got 5 left. Have we got an extra transistor? 1, 2, 3, 4. Yeah, we've got an extra transistor. Well, that's handy because we can put it in the order I want, can't we? 1, 2, 3, 4. Yeah. So all 9018. Yeah. So I'm going to go through these. I'm going to put them in gain order. We'll have the most sensitive at the front end. Right, 122. Extra transistor, that must be worth 4 pence. Right, next one. 119. So that's not quite as good. We'll put that to the right. So our most sensitive is to the left. So we've got 122 to beat. .120. That sits in between. 127, and finally 127. There we go. So what was that? 127, 127, 121, 120, 119. All pretty close, but I know which is going in the front end. So take that off and just check these electrolytic capacitors. Now this looks nice quality. 4.7 microfarad at 5 volts. 4.6 microfarads. There's another one that looks like the same. It is the same value. 4.7. 4.56. And what's these? 100 microfarad. These look a cheaper type. 111 microfarads, that's fair enough. And the fourth one, 104 microfarads. So they all work. Right, I'll probably see you tomorrow with that. So you can see we've got so far, we've got the capacitors in, the resistors in, the transistors in, the diodes in. So what I want to do is put the intermediate frequency transformers, the IFTs, the ones which I've just thrown on the floor. This one, they're actually colour coded. And this is where my tiny writing translation comes in. That's even tinier writing, but there's more of it. I think you have to pay them money to get a proper page. We don't pay people money for things like this. Right, the connections are shown. B2 is the oscillation coil IF transformer, model A3, and is red. So B2 is red. B2 is this reverse way on? Yes. B2 is red. The red one, I don't think this camera's quite in the right position. It's difficult on your own, isn't it, when you're doing things like this. B2, and there is a symbol there which would match up. And it does say 2 in Chinese. So we want the red one of these. And I definitely need to twist these over because it does say in the notes, the translated notes, that it's easy for these to catch on the tuning dial. Right, so first one in. So what have we got next? B3 is the first stage IF amplifier, A2 green. B3 is green. Okay, so none of these are green. B3, B2, B3, B4 is second stage IF amplification, A1 white. So B4 is white. And that goes there. And it shows the symbol. So the next one is black. B5 is the IF coupling transformer, AO black. Okay, so the yellow one is the other one. I just hope that they haven't sent me a yellow one, then when they should have sent me a green one, and then the whole thing won't work because it's got the wrong part. That is the worry. So we're left with yellow, and A2 green. Right, I don't like it when this happens. I'm not going to bend the tabs over on this one, in case we've got to desolder it, and then if it works I can bend the tabs over. It's important we solder the tabs because the earth plane goes through these cans, so they're kind of used as links on the printed circuit. Okay, so we're getting there, and we'll come back to the camera in a bit. Well, Houston, we have a problem. The amplifier's working, the radio's not receiving, so a quick look around, and I brought the spectrum analyzer into play. You know, like everybody making a £5 transistor radio's got a spectrum analyzer, and we're not tuning anything. And I've tracked something down. The, shall we say, the primary of the coil B2, the red one, is open circuit. So let's see if we can see that on the meter. So the secondary with the 3 connections all three connections buzz through, I'll turn it round and we'll look at the primary and it's open circuit. Now then, what we're going to do about that, folks, well, we'll see whether we can see if there's a break in the wire or if it's just not soldered. It's very disappointing though. Who thinks it's very disappointing? Well, I'll have a go at soldering the connections, but I've no reason to believe they're not soldered. And it does say all coils have been pre-adjusted to somewhere near, so they obviously work when they left the factory. Let's see whether that now buzzes through. Nope. I'll see if I can take the coil apart. Well, believe it or not, I've managed to fix it. So, looking again at the primary, we've now got continuity. So it was on this one, and it's, you know, just snapped off at some point. So what I've done is to wrap a single strand of multi-strand wire around down there and soldered it, then laid it across, and I've managed to solder it to the broken wire. So proof the pudding's in the eating. Got all this to put back together. And this obviously is very, very delicate. So that's the kind of holder, and that's the core. And that's the can. And we'll solder it back on the board. By the way, I'm running off my power supply rather than batteries. Set to 300. It's not, it's set to 3 volts. And it's set to about 50 milliamps. So put that back in. Some of you will remember Denko coils from Clacton-on-Sea in the UK. They were big enough not to break. I've seen some people 3D printing their own Denko coils. I took that wire off as a part of my diagnosis. So theoretically it should now pick up the signal generator and the spectrum analyzer and so on. Way. Right, that's an improvement. Not that I can see it on the thingy yet. Let's put that knob back on. I know we've got the dial to stick to that. That should be top of the shop. Weird. We're getting there. That's 1600. Let's see whether it picks up 550. Yeah. I'll take that off. See if we can tune in this station. See if we can move the coil along. We should be able to see this on the spectrum analyzer. Tuning in, let's put that up there. Just put a loose clip on there. We need a bigger coil to pick up the radiation from the radio. I'll come back to you on that. It's not a good demonstration. I mean, it says about 157 kilohertz, but it is at least moving around now as I tune. You can see that one, the peak, is dancing around. It was absolutely still when we got. As we tune things in, it'll tell us roughly the frequency. What I will just do is, I didn't show you this, but we set up the, I'll turn this off, we'll set up the IF at 465 kilo. If I tell you what, we'll do it exactly, because while we've got the spectrum analyzer on, we can set up this more accurately. 465, so we want E, we're on E, and we want, I'm assuming it's 465. So 464.8. .464.860. That'll do me. We'll just move now down to the signal generator, which we've got this our old Advance E2. Take that out to the spectrum analyzer. Stick that coil of wire somewhere near. And we don't have to tune this around. Just move the camera down so you can see what I'm doing. If I can find it, it's there. We can just tune these IF for maximum. Might be able to clip it to one of the cans. Just use the attenuated output. Right, should be able to tune something in now. Let's turn that off, turn the analyzer off. Let's set the tracking. So I'll just put it back in the case. Okay, screwed the board in, put the battery clips in, hopefully got them the right way around, no expense spared. RS Pro batteries. I think that speaker could have done with the terminals elsewhere. I may have to remelt the glue and sort that out. I think the back's probably going to get fouled on the batteries. Or otherwise. I'll put the glue gun back on. One piece of double-sided tape. I can see we're going to be putting some glue on another surface. Situation with that coil though, that's pretty naughty. I don't think many people could have fixed that. And then if you haven't got knowledge of radio, you instead of learning something, it's not going to work out. But there you have it, the WW818. I've not seen this pink one before, so thank you for watching. It's medium wave only.